Hello, I'm Ray McDonald, and I'm an engineer here at ExxonMobil's Global Research and Engineering Facility in Paulsboro, New Jersey. One of the things that I do here is prove out the performance of Mobil 1 synthetic engine oil under extreme operating conditions. An example of an application that runs under extreme conditions is turbochargers. Today, there's a rising consumer demand for better fuel economy but more horsepower with their engine. Engine designers are designing smaller engines to get the fuel economy and then using turbochargers to boost the power and give the consumer what they want. The problem is turbochargers operate under extremely high temperatures. Here, let me show you what I mean. This is what a turbocharger looks like when it's fully assembled and on your engine. This is what a turbocharger looks like on the inside. The way a turbocharger works is it takes the exhaust gas from the engine, flows it past this turbine, which then spins this impeller on the other side. The turbine is connected to the impeller by a shaft. The intake air to your engine flows past the impeller, and as it does, it's compressed, and the compressed air is delivered to your engine, giving your engine more power. Now this shaft can spin upwards of 200,000 revolutions per minute, so it's absolutely critical that the motor oil get to that shaft and lubricate it properly when the turbocharger is operating. The problem is, because it's exhaust gas that's driving this turbine, the internal components of the turbocharger and the oil can get exposed to extremely high temperatures and form deposits over time, which ultimately can cause the turbocharger to fail. Here, let's go see exactly how hot a turbocharger can run. Behind me, in this test cell, we have a high-powered 4-cylinder engine that's equipped with a turbocharger, just like the one I just showed you. Right now, it's running at highway conditions, which is moderate speed and low load. But we're going to ramp it up here to 5,000 RPM and 275 Newton meters, which is equivalent of racing type conditions or some type of driving you might see on the Autobahn. Under these type of conditions, exhaust temperatures can exceed 1,600 degrees Fahrenheit, which is almost 900 degrees Celsius. We have a camera inside to show you exactly what happens to the turbocharger under these type of conditions. What you're going to see is as the speed and load increase, the turbocharger is going to begin to glow red. Wow, that's hot. All right, let's go back to the shop and take a look at these turbochargers and see what happens to them under these type of conditions. One of the most critical components of a turbocharger is the bearing in which the shaft spins. Here we have the bearing from a turbocharger tested with conventional oil. As you can see, deposits have formed on the external surfaces of these bearings, and over time, these deposits can cause the bearing and the turbocharger to fail. Here we have a bearing from a turbocharger tested with Mobil 1. You can see there are no deposits on the external surface of this bearing. This shows how Mobil 1 performs under the extreme operating conditions of a turbocharger. Well, that's all for now. Thank you for joining me here at ExxonMobil's research facility in Paulsboro, New Jersey. And remember, protect your engine with Mobil 1.